Our first speaker is Josh Aas, who is the co-founder and executive director of the Internet Security Research Group. And he will be providing a look back at 10 years of Let's Encrypt.
Hi, thanks for having me. So this is our 10-year anniversary of Let's Encrypt. So I'm going to talk a little bit today about where we are, what we're going to be doing, some principles that have served us well, and some lessons that we've learned. So I'm going to do a very quick overview of the Web PKI. I don't like to make too many assumptions about people who know what's going on here. So certificate authorities like Let's Encrypt issue digital certificates based on demonstrated control of a domain. And control is the key word here. It's not about whether you own the domain or not, it's about whether you control the domain. And when we issue a certificate, the certificate provides a binding for relying parties between domains and public keys. So if you get a certificate and you decide that it's valid, you can use the public key in that certificate to set up a secure cryptographic connection with any of the domains listed in the certificate. So overall, TLS needs encryption and authentication, and certificates provide the authentication part of this equation. So before 2015, when we launched Let's Encrypt, getting and managing certificates was mostly a complex manual process. It was often pretty expensive. And in general, I would say there were just a lot of people who weren't convinced of the necessity of going through this process to enable HTTPS. And the result of that was about 39% of page loads used HTTPS. And that was really concentrated on a small number of big websites that used it. There was a much smaller percentage of overall websites that used it. It was a pretty undermining problem. So I worked on browser networking security before Let's Encrypt. And it wasn't totally pointless, but it felt like it sometimes. So we thought about what we wanted to do, and we wanted a solution that would get the web close to 100% HTTPS within about 5 years. And the reason we were thinking about 5 years is it is basically the fastest amount of time within the realm of possibility. We really wanted to avoid some IPv6 or DNSSEC timelines here. And certificates seem to be the roadblock. Turning on TLS in a web server, it's a config change. It's not that hard. If you want to do it, you can do it pretty quickly. But getting and managing the certificate you need, that's the tough part. We thought about a lot of different possible solutions here, and we decided that in the end, we're just going to have to start a new CA. It's the only feasible solution here. The CA is going to have to give away certificates in a way that it's easy to use and also make the certificates free. And a point that I want to make about free certificates is that it's not just about the money. If you're at a company and you're setting up a website, even if that certificate is 1 cent or 5 cents or whatever, you got to go find a company credit card, get approval to do this. Puts us in an awkward position. If your credit card expires, do we just not renew your cert, potentially take down your site, things like that. The financial transaction part of this is a huge issue for ease of use. So just cutting that out entirely, it's a bigger problem than just how much money we charge people or don't. So by 2013, we had decided to do this, and we really started planning what it would look like. In 2014, we incorporated the nonprofit that hosts Let's Encrypt called ISRG, Internet Security Research Group. We got a bunch of initial sponsors who understood what we were trying to do and were willing to take some risks with some real money. And we started technical development. We moved really quickly, and in 2015, we issued our first certificate. So this is what the graph looks like for issuance from that first certificate back in 2015. Today, this graph is a little bit behind now, but it's about 600 million websites that we serve today. We do that with about 500 million certificates. The reason for that is there can be multiple websites in the same certificate. And then this bottom line here is registered active domains. So a lot of the websites that we serve are subdomains of a registered domain. So the sites we serve are about 150 million registered domains. So I'll talk a little bit about our organizational infrastructure at ISRG. We have about 25 staff total. That includes engineers, fundraising, comms, finance, management. We have 3 projects. Let's Encrypt is our biggest one by far. It's the one most people know about. But we also have a privacy preserving metrics service called DivvyUp. And we also have something called Prosimo, which works on memory safe software. The total budget for this org is about $6.7 million. We get funding from corporate sponsorship, individual donations, grants. So for the CA infrastructure itself at Let's Encrypt, it's operated by about 12 engineers. 3 or 4 at any given time are writing software for the CA, and about 8 or 9 are operating the infrastructure. And to keep these 12 engineers, productive and doing what they need to do, they got a support staff of, fundraising, finance, legal, comms. The physical infrastructure behind Let's Encrypt, it's about 3 racks of hardware across 2 locations. It's HSMs, compute, database, networking. We do use our own hardware. We don't issue certificates with any cloud-based systems at all. One reason for that is that we're required to use our own hardware. But in the end, it has turned out to be very cost effective to just do it ourselves. We know what our load is. We know what we need. We just buy the machines, maintain them, and it's quite cost effective. Physical security is a little bit more intense than a typical data center setup. There's just more layers between the parking lot and the servers, essentially more rules and requirements about who can be where, when, and for how long. We do use the cloud for some ancillary systems, some testing, some log search type stuff, but none of the stuff that's actually involved in issuing a certificate, like I said, none of that stuff is on the cloud. We have a CDN for OCSP and CRLs. Those are our revocation mechanisms. And we have some accommodations in the data center for performing key ceremonies. The software stack is, probably roughly what you would imagine. Linux, virtualization, management. MariaDB is what we use primarily for our database these days, although we've been moving a lot of stuff over into Redis. We have our open source CA software. It's called Boulder. It's on GitHub. We write that ourselves, written in Golang. One of the things I want to mention here is that we've been working hard to transition some of our critical components, especially those that are on the network edge. We're trying to get those to memory safe software. So we started off with NTP. That was like a relatively easy thing to do. We, funded the writing of the software through our Prosimo project, got that deployed. It works great. Later this year, we're going to move DNS over to something called Hickory DNS, which is a high performance resolver written in Rust. We'll be moving TLS over to Russell's and eventually a lot of our reverse proxy stuff over to something called River. So here's the output of that system. We issue about 6 million certificates per day on average. Again, that supports almost 600 million websites. For OCSP, we serve about 15,000 requests at the origin and about 140,000 requests per second at the edge at our CDN. We also run CT logs, certificate transparency logs. We run 2 types of those logs. We'll get into that later. And the total cost for Let's Encrypt itself for a year, so not the whole org, but Let's Encrypt is about $4.5 million per year. So I'll talk a bit about what's coming up next. Short-lived certificates are probably the big one for this year. We currently issue 90-day certificates. That's what we've done since we started the past 10 years. We have now issued our first 6-day certs. We've only issued them to ourselves, but we are going to be opening it up to a wider and wider audience and general availability by the end of this year. The shorter lifetimes are better for security. If you have a key compromise, you don't need to worry about janky revocation mechanisms. It expires in 6 days. You get a new cert. If your renewals are automated as they should be, this should not have any impact, but this is optional. You're not going to be forced to 6-day certificates. You can stick with 90 by default, and you can opt into 6-day certs. With 6-day certs, we're going to be adding IP address support. So right now, you can only get certificates for domain names. You're going to be able to set up TLS with IP address soon. That's only going to be available on the 6-day certs. IP addresses tend to be a bit more transient than domain names, so we don't want to issue IP address certs for 90-day validity periods. That'll only be on 6-day certs. We're also in August going to turn off OCSP, so that 140,000 requests per second that we serve, that's going to go away. There are a bunch of privacy problems with that. We don't want to know every time somebody uses a Let's Encrypt cert to visit a website. We currently don't store those logs, but we don't want this traffic at all, really. It's expensive to operate. And because OCSP signing is so much more frequent than the signing of certificates themselves, actually it's something like 75% or more of our HSM capacity is taken up by OCSP signing, and the remainder is the signing of the certificates themselves. So it'll free up a lot of space in HSMs. We're also going to continue to push Acme renewal info hard. And this is a system where you can have your Acme client check with Let's Encrypt every day or every few hours, whatever you feel like. And you can say, should I got a new certificate yet? And often we'll say no, but if we're going to revoke your certificate sometime soon, we might say, yes, get it now before you normally would. That means if we revoke your certificate for some reason halfway through the certificate's lifetime, ARI will signal to you that you should get a new certificate now before we revoke it, and we avoid a lot of downtime. So this is a really important part of improving resiliency for the web PKI. And if anyone here happens to be an Acme client maintainer, we should talk about this after. We're also going to be evolving how we handle transparency logs. So like I said before, we run 2 of those in 2 different styles. The old style, I would say at this point, RFC 6962 logs. We've been running those for a while now. But the goal is to try to make running these logs easier and cheaper and make them more reliable. The problem with RFC 6962 logs is that they essentially require a large and expensive cloud-managed SQL database. Those databases, because they handle dynamic queries, they can be relatively easily overwhelmed. They also suffer from something called max merge delay violations, where we say, we will stick this certain CT log by a certain time, but then if we fail to meet that deadline, the log can be disqualified and things like that. And there are ways to get around that, which I'll get into next. But generally speaking, these logs are just complex to run. They're expensive in terms of cloud costs. They're expensive in terms of staff time. We do run these in the clouds because these are not involved in certificate issuance. So we're going to move to something called tiled logs. And instead of doing dynamic database queries when people want to query the log, we just return really easily cacheable tiles of responses. I think Filippo Valzord is here. He did a lot of work to help make this happen. We're very thankful to him for doing that. It moves a lot of the storage burden to S3. And like I said, we can just use a CDN. We don't need this big managed database. It also gets rid of the max merge delay. We just don't hand out the receipt for the addition to the log until we've already added the cert to the log. So no more max merge delay violations. So the last thing, this isn't something that's coming up, but it's worth noting that it's not coming up. We're not really working on PQ yet. There are a bunch of things that need to happen before it makes practical sense for us to engage with this topic. So the web PKI community is going to have to agree on a plan. The root programs are going to, and the CAB forum, they're going to have to agree on some rules that allow us to do PQ. Right now, even if we wanted to, we can't. And then once we're allowed to, we need HSMs that support PQ algorithms. Now, HSMs are hardware security modules. They do all of the signing for us, and they keep the keys private. For those who don't know, HSMs often have this thing where they support some algorithms in hardware, and those are really fast, and then they support more algorithms in software. At our volume, we need support for PQ algorithms in hardware. An HSM that does like 1,000 signatures per second is not that useful to us. We cannot afford that many HSMs, either in terms of the hardware, the support, or the power budget. We probably need HSMs that can do 10,000 per second, and that means we need HSMs with hardware support. HSMs do not evolve quickly for people who are not familiar with this type of hardware. So this may be the long pole here, and I hope there are people working on this because we need hardware support in HSMs for this to be practical at scale. So I'll talk about some principles that have served us pretty well over time. One of them is simplicity, and this is maybe the biggest one. The web PKI, their requirements and the technologies are pretty complex. They're not easy to implement. They're not easy to use normally. We try to encapsulate as much of that as possible and expose it as simply as possible. It's good for ease of use, it's good for security, and it's pretty good for financial stability as well, sustainability. We're always looking at a way to cut down on things and make them more simple. An example is that we just have one API for getting certificates. There was no other way to do it. We can't even do it another way internally. If we internally want a certificate, we get it the same way everybody else does. So there's only one sort of compliance surface, one attack surface for us. We also applied this principle to our internal database architecture. We have a single instance. We don't shard or cluster. Now because of this, we have very powerful machines. They cut into the 6 digits per machine, and we have a few that we can, more than a few that we can switch between when we want to. There are live replicas. But we could and do run the database on one machine unless we need to switch over for some reason. It has been great for maintenance, right? It's much easier than maintaining a cluster. The hardware is expensive, but it's cheaper overall to do it this way. We might be nearing the end of the strategy. We might have to cluster or shard sometime soon here. But I mentioned before, we've been kicking stuff out of SQL and over into Redis. That's worked out great, and we have a little more headroom on the SQL machines than we thought we would at this point. So maybe it'll last another year or two. We'll see. We have to be efficient. It's our financial reality. We can't just throw a lot of money around and stuff that's not really necessary. It's also the right thing to do. I'm really thankful that people entrust the dollars that they have to us to do our work, and we should do the most good that we can with the public benefit dollars that come our way. An example of this is scaling. So we cannot scale our staff or our hardware, frankly, but mostly our staff with issuance. We can't, that graph earlier that I showed, we can't have a graph like that for staff. Every year we need to be a bit more efficient than we were the last year. So this is just some snapshots in time. We started with 4 engineers. Somewhere in the middle, we got up to 8 or 9 engineers. Today we have 12, but the issuance, the people we serve has gone up much faster than that. So I'm proud of the team for getting this done, and we need to continue doing it over time. We make decisions that optimize for staff time a lot. This goes back to what I was talking about with the hardware. It's much cheaper to just buy a big database that will do the work than shard it out and spend a lot more staff time dealing with that. So another principle that's important to us is transparency. An example here, when we started off, I did not know how a CA worked really at all when I decided to build one, nor did my co-founders. We made a bunch of mistakes, and we decided early on, we're just going to be transparent about all of them. Every time it happens, we're going to post, we're going to explain what happened, what we're going to do about it. And some people worried if you start doing this, which wasn't as common back in 2015 as it is now. If you start doing this, people are going to trust you less. But I think quite the opposite happened. The fact that we filed incident reports as we learned and made some mistakes made people trust us more. And it's worked out well for us, and we keep doing that now. We also have open source CA software. Not all, let's say there's 100, publicly trusted certificate authorities out there. I don't know if that's the exact right number, but it's the right ballpark. Not all of them write their own software. It's an expensive undertaking to do that, given how many rules there are on the Web PKI. But this is important to us. We need to do this, and it's open source. People can see exactly how it works. We've had people find bugs preemptively in our issuance just by looking at the open source software. It's worked out really well for us. It also helps Acme client developers. You don't just get to see the Acme spec from the IETF. You can look at exactly what we do by looking at this software. So for some lessons, one of our staff brought up when I was asking about this is that mercifully, Let's Encrypt is not involved in every TLS connection. Our certificates might be, but you don't have to contact us about it, especially if you're not using OCSP, which we're going to get rid of. Well, I think we'll talk more about that later, but yeah, we're not in the hot path. That's great. We should think about this when designing other web scale services, like how can you let the connections happen without the service they depend on being in the middle there. Open standards can help. It's probably not a shocker to a lot of people in this room, but having an open standard has helped us build such a vibrant client ecosystem. It's much better than we could have. People might be surprised to learn that we don't produce any client software or distribute it at all. We worked on this open protocol, we run the server side, but all the client software out there is built by our community. We thought about this early on. We dipped our toes in this a little bit, but there are too many deployment environments out there for us to begin to try to cover much of it. So we really focus on open standards to help get the client ecosystem to be vibrant. We focus on what's important. This is related to some of the earlier stuff we talked about, but you can't do it all and you can't make everyone happy, especially if you want to be efficient. There's all sorts of stuff we don't do. We don't do OV, we don't do EV. We're going to kill off OCSP. There are not too many support options, like you can't call people up at Let's Encrypt and ask them how to get a cert. There's a non-trivial number of people that are disgruntled that we don't do SMIME certs. We can't do everything. We spend a lot of effort doing things that are important. Like I mentioned before, our CA software, like we didn't have to write that ourselves, but that is really important and we do that. The last one here goes back to something I mentioned earlier. Hardware is cheap. Like we learned this lesson over and over again. It is just cheaper to buy better hardware and spend less staff time doing stuff. I have an example here. This is what our database servers look like. There are a couple Epic chips, 2 terabytes of RAM, and a big pile of NVMe disks, sort of rated together with OpenZFS. It has always been cheaper to do this. These are over $100,000 machines, but it saves us a ton of money to do it this way. My last lesson here, I think, is around intimidation and uncertainty. When we started Let's Encrypt, we didn't really know if it was going to work. It was sort of intimidating to some of us. Early on, after we decided to build a CA, I started asking her, like, what's an HSM? Apparently we need those, Don't be intimidated. There's lots of things that need to be improved on the internet. Give it a shot. We had to create legal entities, hire staff, fundraising, get trusted by the browsers. It was a very intimidating project to start with. It worked out fine. I'm sure everybody here is smarter than I am, so figure it out. It wasn't an insurmountable work. It was totally worth it. And billions of people have a safer internet today because of it. Here's some ways to help. Thank you.
We have some time for questions.
Very common attack vector is to try to benefit from typos. So Google with the O's replaced by zeros can lead to a malicious website. Are you providing any help in preventing such mistyped addresses? Or you'll provide a certificate even if it's obviously close to a famous website?
We do not do that kind of filtering, no. There are other people who are better equipped than that. That kind of stuff generates a lot of false positives, and at our scale, like, we're not prepared to deal with those false positives. And yeah, we do not do that.
Thanks. Hi, thanks for all the work. 2 questions. 1, 6 days. And then 2, are you guys interested in hosting all kinds of privacy-preserving infrastructure like?
Sorry, I can't hear the second one.
Are you guys interested in hosting more privacy-preserving infrastructure like the systems you already have? I'm blanking on the name of it.
Well, to answer the second one first, yes, we do look at other infrastructure that might be helpful to host. So why 6-day certificates? There's a few reasons. One goes back to, like, eventually we're going to be required to. So the way the rules work now, that a short-lived cert is defined temporarily as 10 days. In a few years, the definition is going to drop down to 7 days for compliance purposes. So we don't like to be on the edge of compliance at all, and we don't want to make another switch from, like, if we were targeting 10 days, we would do 9-day certs so that we're not living on the edge. But we don't want to target 10 days because a few years we're going to have to switch down to 7 days. So we picked 6 because it's 1 day less than the compliance of 7. It also is just rules aside, it gives you enough time to get a new cert if you have a problem. It's also where doing things like IP address certs becomes reasonable, right? Like IP addresses change a lot, but for the most part, not every 6 days. Yeah. One of the things that I didn't mention about short-lived certs too is that they don't have required revocation mechanisms. So we want something that's pretty short. So if you do have key compromise, you don't need to rely on, it'll wash out of the ecosystem pretty quickly.
Thanks.
So you make a big impact within Let's Encrypt with a rather small team. Do you have any staff turnover? I also understand that as a CA, you have to very much look into any new staff coming into the team. Could you tell us something about that?
We do vet our staff, we do background checks, interviews, things like that. So we definitely vet them. Turnover is not that high. I think people generally enjoy working on things that have impact and are open source. So, I'd like to think it's a nice place to work. We don't have a lot of turnover. Yes, we do check our staff. It's background checks, lots of documents and legal agreements, things like that, maybe a bit more than you would normally have.
Thank you.
Hi, thanks for the talk and the great work. I have a question. So on the slide, when you showed the graph of active certificates, so I think between 2023 and 2024, there was like the sharp temporary decrease. So I was kind of curious to like, what's the, yeah. what's the reason? Yeah, yes.
Yeah, every once in a while there's a sharp drop. Honestly, the really sharp drop, I think that is an issue with the statistics gathering. It's actually pretty hard to calculate this graph because it's not a simple counter. It's like you have to do a ton of deduplication to figure out what the actual number is. So it requires way more resources than we would expect to produce this. And every once in a while, the way that it collects stats gets messed up. And I think that really sharp drop is just something where it got messed up and we did not fix it entirely properly.
Thank you.
Hi, again, thank you for the talk and your work. I was wondering if you could tell us a bit about your key ceremony and an HSM setup specifically in order to protect against like single employee weaknesses. I would imagine you're pretty paranoid about exposing the private key of your root CA.
Yeah, so we do key ceremonies. They're done in a room that has a lot of walls between that room and the outside, right? It's not against the edge of a building or anything like that. Trying to think of how much I could say about this. We limit the device in the room. We do think about EM radiation, things like that. I think one of the biggest things we've changed over time is that when we did our first key ceremonies, they were not as automated as we would have liked. So our first key ceremonies took longer than they do now. Now they're over in a matter of minutes because the whole thing is like scripted out and checked, that has a bunch of automated checks in place. And, people running the ceremony are mostly like pulling HSMs out of a safe, putting them on a table, verifying that the cables are set up. They get the laptop going, which is like a special secure laptop that doesn't go on the internet. And, they load the script for the ceremony, which is pre-populated with what we want to do. And they're basically just hitting a button and it's over in minutes and we pull the certs off. So I think the speed of the ceremony has probably been the most important for us over time. And the automated stuff is just more reliable. There's less room to make mistakes. But yeah, we do think a lot about who's in the room, where is this room. There are a lot of special safes with special ways of getting into the safe where the offline HSMs are stored. For people who don't know, the root keys at Let's Encrypt, and I would assume /hope at the other CAs, are typically kept offline in tamper bags and special safes, which are themselves inside many other layers of security, and only the intermediate HSMs are online and in a rack. So, yeah, does that
Thank you.
answer
It
your
does.
question well enough?
It does, thank you.